So in this video, we'll look at the topic of limit again, and by what you learned in differentiations. And we have a new rule, which is called L'Hopital's rule, that can help us to find the limit to certain problems. Let's look at the picture here. I'm asking you to find the limit x goes to a for the fraction f of x divided by g of x. If you see the following situation. After replacing x by a into the fraction, so it means numerically, you should be trying to find f of a divided by g of a. If this one is something like 0 divided by 0 or infinity over infinity, these are the items which we call undetermined items. These are the items where you don't know the answer yet. Please don't think the answer is 0 or infinity. They don't have to be. So it means that cannot determine the answer at this stage. You have to rely on other methods. And L'Hopital's rule is actually very helpful in this situation if you understand differentiation well. The fact is that by L'Hopital's rule, this limit is actually going to be the same as the limit x goes to a for the corresponding quotient for f prime divided by g prime. So of course, f prime and g prime are the derivatives, right, of the corresponding functions. So now you have learned the differentiation rule quite well, and you understand the meaning of limit and the meaning of the undetermined items. So let's do some exercises together. So please look at the current item. I'm asking you to tell me the number for the limit x goes to 1 for the current fraction, and as a useful first step, usually you can try to replace x by 1 into the fraction to see what's happening. When you replace x by 1, you'll see that you're getting 0 over 0, which is the undetermined case, and it means that we can directly use the L'Hopital's rule. So by L'Hopital's rule, it means that instead of doing other calculations, you can find the derivative for the numerator function and the denominator function separately. And let's find the derivative first. The derivative for the top is going to be 8 times x to the power 7. And for the bottom, it's going to be 9 times x to the power 8, right? And now we can, of course, algebraically cancel out the common factor for the top and the bottom. We can cancel out 7 copies of x. So we are left with the fraction h over 9x. And then we can directly replace 1 into the x. So the answer is h over 9 times 1, which is h over 9. This is the answer to this problem. Let's look at this current problem where the limit is for x goes to infinity and the fraction is ln x over x. And once again, we can do a shortcut. So conceptually, please think about that. When x is infinity, it means that conceptually you're dealing with ln of infinity divided by infinity. And please recall that the ln function as a graph is always an increasing function, although it is increasing quite slowly comparing to other functions. But anyway, conceptually speaking, you're actually having infinity over infinity. Please don't make the mistake that it looks like you can cancel the infinity out. The answer is 1. Please don't make this mistake. As I've said a little bit earlier, infinity over infinity is undetermined, which means that you don't know the answer yet. And for now, we can apply the L'Hopital's rule, and it means that it's the same as the limit x goes to infinity for the fraction where you can find the derivative top and bottom separately. So the answer is limit x goes to infinity. For the fraction now, the top is the derivative of ln x, which is 1 over x. The bottom is 1, right? And let's look at the current fraction, which is 1 over x. And please try to understand that if you replace x by infinity into the quotient here, conceptually, it's the same as 1 over infinity, right? And 1 over infinity is 0. So the answer to this problem is 0. And we can look at other exercises. Let's look at the current problem instead. As a good shortcut, we can do the following. Let's think of x as infinity. So let's check what's happening conceptually to the quotient we have. The top is ln of infinity, the whole thing square, and the bottom is infinity, right? When x is infinity. And as I said before, ln of infinity itself is infinity. So you kind of have something like this. So which is once again an undetermined items. And it gives us a chance to use the L'Hopital's rule as follows. And this one actually equals limit x goes to infinity. The bottom now becomes 1 because it's the derivative of x, right, in the bottom. How about the top? The top should be the derivative of ln x, the whole thing square. And we can apply a chain rule. So by power rule is 2 times ln x, and it needs to be multiplied to a second factor, which is the derivative of ln x. So I'm applying a chain rule here. And let's try to understand this fraction together. Now the fraction becomes 2 times ln x at the top divided by x. And once again, if you replace x by infinity now, conceptually, you still have something like infinity over infinity still. So which means once again it's an undetermined item, and you don't know the answer by this stage, but it doesn't matter to us because as long as we use the L'Hopital's rule, we'll see what's happening. So if you use the L'Hopital's rule now, for the top and bottom, we find the derivative separately. The bottom is 1, the top is 2 times 1 over x, which means now you are looking at the fraction 2 over x. And because x goes to infinity, it means conceptually this item is the same as 2 over infinity, which is not undetermined anymore. 2 over infinity is conceptually the same as 0. So that's the answer to this problem. And we can do something more. Let's look at the current problem. We are taking the limit x goes to 0 for the product of two functions, tangent of 3x times cosecant of 2x. And let's do a quick check by replacing x by 0 inside to see what's happening. When x is 0, we are having tangent of 0 times cosecant of 0. And please note that tangent 0 is actually 0. And let's look at what's happening here. Please remember that cosecant function is the same as 1 over sine. So this one is conceptually the same as 1 over sine 0, which is 1 over 0, which is conceptually the same as infinity. So which means now as a product, it looks like 0 times infinity. And please think about this. This one is actually an undetermined item. So 0 times any fixed number is 0. However, now conceptually this case looks like it is 0 times infinity, which is an undetermined case. You don't know the answer yet, which is undetermined. And just to let you know, our L'Hopital's rule cannot be applied to a product. So the better way to deal with this problem, if you still want to use the L'Hopital's rule, is to make the product look like a quotient. And if it is in a quotient form, if it is undetermined, of course we can apply the L'Hopital's rule, right? And for the current problem, the best way to use the L'Hopital's rule is to write the cosecant function as 1 over sine. So instead of looking at the product in the first line, we can look at it as a quotient instead. So we are making use of the fact that the cosecant function is the same as 1 over sine. And now this one is still undetermined case because when x is 0, it actually looks like 0 over 0, which is undetermined. So it's still undetermined. And which means we can use the L'Hopital's rule as follows. Now the problem becomes limit x goes to 0, and because I want to find derivative of the top and bottom separately, let's do the bottom first. It is the derivative of sine of 2x, and we can apply a chain rule, so it becomes 2 times cosine of 2x, right? And how about the top? Please recall that the derivative of tangent x is secant square. So secant square of 3x. And as a chain rule application, we have to multiply to a second factor, which is the derivative of what you have inside the bracket. So it's going to be 3. And let's look at this problem together now. So let's try to replace x by 0 into the fraction to see what's happening. If it is not an undetermined item like 0 over 0 or infinity over infinity, we can actually write it as the answer, right? And let's look at this fraction together. The bottom is 2 times 1. How about the top? The top is actually the same as 3 times 1. And actually the answer is 3 over 2. Of course, it is a fixed fraction, which is not the same as any undetermined item, right? And that's the answer to this problem.